Hello everyone, today I'm going to talk to you about continuity for a function. And basically, concept for continuity is that you could draw that function without picking up your pen or your pencil, so you could just do a smooth function. So if you drew something like, if you remember what x squared or quadratic looks like, it looks like this. And this would be a smooth function because we didn't have to pick up our pen or pencil to draw it. Something that would cause us a problem would be if we had to go along like this. Say that it jumps down here and then it goes down like that. This is going to be a problem because we had to jump it. Anytime you had to pick up your pen or pencil, it's going to violate continuity. But continuity actually has rules we could check. So we could check each point on the function to see if there's a certain point on the function where we fail continuity. Because here, like the rest of this, outside of this spot here, the rest of this function will be okay. So the three rules we have is, the first one is that it has to have a limit. The limit has to exist. The second rule is that it has to have a point. Point has to exist. And at this same spot, these two people, limit and points, have to be equal to each other. So whatever we get for the limit value has to be equal to the point value. So why don't we go ahead and look at this funky graph over here to check for continuity. So let's just go across. So here, at x equals 1, let's say we want to know, is this function continuous when x is equal to 1? So for x equals 1, we want to check continuity. So we need to check all three. So just be careful. For limits, you need the left and the right to match for the limit to exist. So the left line and the right line have to be at the same point. So here, this goes to here, this goes here. They both land at a height or a y value of 2. So yes, this limit does exist. So the limit of this function as x approaches 1 is equal to 2. So we satisfied the first one. Second thing says, does a point exist? Back in your days of algebra, closed circle meant that the point existed, open circle means there's no point. So since this is a closed circle, we would say yes, there's a point. And we'd say that the point is equal to 2 as well, right? So the closed circle has a height or y value of 2. Then we just have to check the third step. Are these two people the same? This is 2, so yes, limit's equal to 1. So yes, this function is continuous at x is equal to 1. But we had to check all three. If we fail at any point, we're allowed to stop. So if we say the limit doesn't exist, we don't have to check the other two people because it's automatically going to fail. Failing any of these rules is going to fail continuity. Let's say we want to check x is equal to 2. So without going through the rules, just looking at this person, see, to go here, we'd have to pick the pen and pencil up, go down here. So it seems like it should fail continuity because you're going to have to pick your pen or pencil up to draw that. So if we test this, we look at this person, look at the limit. So the left side limit goes here, the right side limit goes here. These two lines aren't meeting at the same point anymore, right? This is at 2, this is at 1. So since these lines are meeting at different spots, there's a gap, which means the limit does not exist. So since there's no limit, we can automatically say no. You do not have to continue checking the other rules. So let's check x is equal to 3. So going down the list, first we check the limit. So at 3, the line on the left and the line on the right both do meet at the same spot, so that's fine. And they're meeting at a height or y value of 1. So since these two lines meet at this spot, the limit is good. We can say the limit of this function f of x as x approaches 3 is equal to 1. And we satisfied the first rule. Now I have to check, does this work? So there's an open circle here, but there's no closed circle hanging out anywhere else at x is equal to 3. So that means there's no point here. So we're going to fail this because we're going to say if there's no point, then this is going to be a no. So if there's no closed circle at any spot along x is equal to 3, we automatically have to fail it. So now what we're going to try to do is the last one, which is going to be tricky. We're going to check continuity at 4. So at 4, it's going to be a little trickier. So let's see what happens. So looking at 4, the line on the left and the line on the right both meet at x is equal to -1. So we have a limit. The limit of this function as x approaches 4 is equal to -1. So we satisfied the limit. It does exist. We check for a point. There is a closed circle hanging out way up here at 2. So we do a points as well. So limit, we have a point. But we have a problem. Limit has to equal a point. So -1 does not equal +2. So we're going to have to fail this because the limit is not equal to the point. So this is going to be a nil. But those are the 4 cases that we can have. Either they all work, or we can fail the limit, we can fail the point, or we can fail limit not equal to point. And that is basically the rules of continuity. But visually, the easiest way to tell is you could say, I can't draw this without picking up the pen or pencil. So this person is going to fail. This person, you'd have to pick up to draw that one, so he'd fail as well. This one's a little bit tricky because a point doesn't exist. But a lot of times visually, you can just tell if there's a jump or an open and closed circle, it's automatically going to fail continuity. Here you might just want to check it because it looks like it could pass, but it's going to fail because there's no point. And that's how continuity works.